Okay, so we've been given a little bit of help in the previous two problems where we've been given part of the solution. We've been given 1, 0. In this case, as you can see, we're not given any zeros. We're just being asked to find them all. Well, let's take a step back and answer why we can't immediately just go find them really quickly. Well, if you think back, if we are given a quadratic, we could always go back to the quadratic formula, or we could try to factor, etc. But if something is cubic or higher, fourth power, fifth power, etc., we don't have a clear-cut technique that we can just go to and use. In this case, for example, factor by grouping would not work, so that's out. I don't have a quadratic formula because it's a cubic. So we've got to figure out, well, what can we do to go find all the zeros? Well, we know there's going to be 3, so let's kind of address that. We know there's going to be 3, so I have to go find all 3. Now, we have a little tool that's going to help us, and that's called the calculator. Way back when, before we had the graphing calculators, it would have been a lot harder to do this. In fact, sometimes I wonder how rough it was like back in those days. So let's see. Old school classrooms. Let's see what that would even look like. All right, let's see what we got here. Some images. Yeah, this looks pretty rough. Look at all these eager kids, or how about this one? So this is old school classroom. They definitely did not have graphing calculators back then. I'm sure you would not like to see me wearing that outfit there. Anyway. Before graphing calculators, this would have been much harder. You would have had to use what's called finding all the rational zeros first. So it's called a P over Q list. And I'm not going to get into that now because that takes much, much longer. The advantage we have is we can use a graphing calculator to get us started. So what I'm going to do is I'm going to take that quadratic, or not this quadratic, this cubic that was given to me, and I'm going to put that into the calculator. So it's going to be 15x to the third. So let me get to the front there. All right, so I have 15x to the third. Oops, got to get on the outside. Sorry, 15x to the third. And then I have plus 61. So plus 61 x squared plus 2x minus 8. Okay, so there's my graph. Now, as you can see here, I'm hitting the x-axis in 3 spots. 1, 2, 3, which tells me that I don't have any imaginary zeros. So that's good. They're all going to be real. I need to pull one x-intercept off of this graph. Only one. My advice to you would be pick the clean one. This is not clean. This is not clean. This is clean. So I'm going to take -4, and I'm going to write that one first. I know that x equals -4 is a 0. Now we are right back to where we were earlier in the section, which was given 1, 0, find all the zeros. So I'm going to take -4. It really doesn't like my -4s, so I'm going to have to learn how to do that a little better. Here we go. -4. There we go. Okay, so -4. I'm not missing any terms, so 15, 61, 2, -8. I know the remainder is 0, so let me just go in there and put that. So I have 15. Remember, you drop that down, and then I add vertically, multiply diagonally. So 15 times -4 is -60. So that gives me 1, -4, -2, +8, and I did it right because my remainder is 0. So we're on our way. So now I've created the quadratic from the original. So I've taken out my 0 of -4, so now I'm down to 15x squared plus 1x minus 2. Now I need to take that quadratic, and just like we did in the first tutorial there, I'm going to set that equal to 0 and use a technique. Factor it. Use the quadratic, whatever you want to go with. I'm going to try to factor it again. So I want to think of my factors of 15 and my factors of -2. So I'm going to start with 5 and 3. Let me switch my color here. I'm going to start with 5 and 3. Again, this is technically considered guess and check. I'm going to try +2 and -1. Multiply my diagonals, that gives me -5. This gives me +6. That does add up to be +1. Therefore, my two factors that I was looking for are 5x plus 2 and 3x minus 1. Okay, so my missing zeros are -2/5 and +1/3. So if I put it all together, my initial zero that I found was -4. And then I used synthetic division to break it down into a quadratic so that I could find the last two. So if I were to write my solution set, I have -4. I have -2/5. And I have +1/3. Now, that's it. Let's go back to the graph and make sure that we're right. We knew that it crossed at -4. -0.4 is equivalent to -2/5, which is what we got. And 0.3 repeating is equivalent to 1/3, which means that we